Bismillahirrahmanirrahim. So today we will be talking about the absorption of electromagnetic radiations by the molecule. In the previous topic we deal with the basics of the spectroscopy, where we said that here basically in this branch of spectroscopy electromagnetic radiation interacts with the matter. Fine. Now that interaction gives us the information about the structure of the molecules, fine, and atoms. Now here we'll talk about the absorption of that electromagnetic radiation in the matter. As I mentioned earlier in our last lecture, the electromagnetic radiation interacts with the matter, and that in turn what this interaction provides, it gives us the structure of the molecule. Structural information, bond length, bond angle, the nature of the bond, the twisting characters, the aromatic nature, and so on. So it can give the structure of the molecule, right? Structural information. So interaction of your electromagnetic radiation with the matter finally gives us the structure of the molecule. Fine. So today we'll talk about the absorption. How now once the electromagnetic radiation interacts with the matter, so what happens? The various phenomena may happen here. It may be the reflection, it may be refraction, it may be diffraction, it may be scattering. So we'll be dealing with, actually in general, we generalize the phenomena. We'll be dealing with that. We're saying in the sense that the molecule interacts with the electromagnetic radiation and then the energy gets absorbed. Fine. As per the relation of E is equal to h nu hc by lambda. So this is the energy associated with each photon or each quantum of light, as we discussed in the quantum theory. So this is the relationship. Fine. Now once the radiation interacts with the matter, first of all, from this relationship the energy is quantized. With each quantum of radiation the energy associated is this much or this much. So first suppose thing is that energy is quantized. Number 1 point. So energy is quantized, and same is the case that the molecule will absorb only those frequencies which will provide which will provide it with the exact quantum of energy. So the molecule will absorb only those frequencies which will provide the exact quantum of energy, or the integral multiplies. So the molecule will absorb either one quantum of radiation or two quantums of radiation, and so on, n quantums of radiation. So thus we can say when an organic molecule interacts with the electromagnetic radiation, it may lead to the change in the energy, as we have seen in the earlier class of when this molecule interacts with the electromagnetic radiation, and this is the energy associated with each quantums. So this interaction and absorption, it leads to the change in the energy of the molecule, as we have seen in the previous class. You can show it here. So this absorption will lead to the excitation of molecule from ground state to the excited state. So let's say this is the ground state and this is the excited state. So when the molecule absorbs the radiation, it leads to the excitation from ground state to the excited state. Show it here. Now once molecule absorbs the energy, a specific energy which is present in that particular photon, and then it goes from this state to this state. Now this is called as the absorption. So a molecule going from ground state to the excited state, it's also called excitation. Now this called as the spectrum which we'll get from this transition. It's called absorption spectrum. So this is the case of absorption spectrum. So this is the case of molecule going from this state to this state. Ground state is called as absorption spectrum. And now if a molecule comes from higher state to the lower state, so I'll show it here. A molecule goes from excited state to the ground state. So it will release the energy. It's coming from higher energy to lower energy. It will release the photon of energy. It's called as emission spectrum. So this phenomena, which will be recorded by the instrument of the molecule, comes from excited the ground state. This is called as emission spectrum. These will be dealing later, emission spectrum. Fine. So this is the absorption. I'll show it here again. I'll just show the slide. So this is the absorption and this is the emission spectrum. Fine. So it's called absorption and emission spectrum. So we can in a nutshell say that once we expose the molecule to the radiation, it leads to the absorption of the radiation, and from this absorption we can actually, it alters the energy of the molecule, and then it leads to the excitation of molecule. And same is the case, once molecule excited can come back, and that phenomenon is said to be called as emission spectrum. Now important things actually we have to see today, that this molecule or the matter, it absorbs the radiation. Now which type of radiation it will absorb, there will be a change accordingly. There will be a change in the ground and excited states. Actually in the molecule we have different types of energy levels. So for example, as we have shown here, it is just E for electronic energy levels. We may have the rotational energy levels, vibrational energy levels. We may have the nuclear energy levels. So which type of transition will take place, which type of change will be there in the molecule, so that will be determined by the type of radiation. Fine, in general. So now that phenomenon, now in order to deal with the type of radiation the molecule absorbs and which type of change occurs, so that we'll discuss in the form of a table, which you can have correlated this with the electromagnetic spectrum. So electromagnetic spectrum and the type of molecular, the spectrum, that means which type of radiation we are using, whether it is high wavelength radiation or low wavelength radiation, and then accordingly there will be a change in the molecular energy levels. That's called a molecular spectrum. So here you can see the table. So this is radiation, this is the wavelength of particular radiation, and this is the spectrum. That means which type of change will occur and what is the terminology we use. Now number one, radio waves. Fine. Now this is in our electromagnetic spectrum. This is the high wavelength wave, which is low energetic. So this is high wavelength wave, or it is low energetic wave. Now there was some problem in the electricity, anyway, no issue. So this is your radio wave. So what radio? It has a wavelength of greater than 100 nanometers. So I have written here NMR, that is nuclear magnetic resonance. This we have a chapter, we'll discuss it there. But here we'll just say that once molecule is exposed to radio waves, upon absorption of radio waves, there's a change in the nuclear energy levels, or the nuclear transitions will occur in the molecule, and then it is designated by a spectroscopy called as nuclear magnetic resonance spectroscopy, and that spectrum obtained is nuclear magnetic spectrum. So the next wave, which is of better frequency than radio waves, I can see lower wavelength than radio waves. It's called as a microwaves. Once a molecule interacts with the microwaves, so which has a wavelength of 1 to 100 nanometer, 1 to 100 millimeter rather, so this was millimeter. So it reaches the rotation of the molecule. The molecule undergoes rotation. So this radiation, it brings in rotational change in the molecule. I can see these energy levels are now rotational energy levels, R1 to R2. So there's a rotational energy level. So this spectroscopy is called rotation spectroscopy. That also we'll see separately. The next one is infrared radiation. Fine. So it has a higher energy than microwave. So these are basically increasing order of energy, or you can see we are going with the decreasing order of frequency. So infrared radiation has the wavelength in the range of 50 micrometer to 2.5 micrometer, and then it leads to the vibrational change in the molecule. That's the vibration in the molecule. So the molecules undergo vibration, or I can see it leads to the change in the vibrational energy of the molecule. So here, instead of electronic energy, we have V, vibration energy. So it leads to the vibrational change in the molecule. That's called a vibrational spectroscopy or infrared spectroscopy. So the next is UV visible. That's visible ultraviolet radiation. I shown them here in the form of visible by UV. It's because both are they lead to the electronic changes in the molecule, electron transitions. So visible does, it's the range of radiation which our eye is perceives, human eye. So it's 380 to 780 nanometers, and in case of ultraviolet is 200 to 300. So it leads to the electronic transitions in the molecule. Actually, you could see here E1 to EV. That is the electronic energy. So the electrons, they undergo transition from ground state to excited state. Now as shown here, it is valence electrons. Fine. So valence electrons means, you can try it here. If we just put up like a Bohr's model kind of a structure, this atom in a molecule. So this is a 1, 2 energy levels, 3, 4, 5. The ones which are on the outside, these are called valence electronic energy levels. Inside, these are called ground, the core electronic energy levels, these which are inside the atom, close to the nucleus. So ultraviolet visible spectroscopy, basically it leads to change in the valence electronic energy levels. And then we have one more that's called X-ray spectroscopy. Okay? So it's also a complex branch, but I'm just highlighting it here. So it is frequency, wavelength is 100 picometer to 10 nanometer. See, it's high frequency, low wavelength. And it also leads to electronic energy level change, but then it involves the core electrons. While in case of UV visible, it involves the valence electrons. Again, I'll show the table here. So this is the table, radio waves, and then, so this order, this is basically the increasing order of frequency or decreasing order of wavelength. So this is called electromagnetic spectrum. And on the right side, we have the changes which take place in the molecule. Here we have changes in the nuclear energy levels. In this case, rotation of the molecule. In this case, it leads to vibration of the molecule. In this case, it leads to the electronic excitation. In this case, it leads to this is the electronic excitation, but that's the core electrons. So this is, now we can see that once the electromagnetic radiation interacts with the matter, then this interaction, what it does, the type of the energy is absorbed by the molecule. So which type of radiation we are using, accordingly there will be change in the energy levels or the change in the molecule. If we use radio waves, so there will be change in the nuclear energy levels, and accordingly we'll get the structure of the molecule based upon that particular change in the molecule. Fine. So this is, I will highlight it here. So this is our board now. Fine. So this is the absorption of electromagnetic radiation by the molecules and the types of electronic transitions. Now, before we move, I want to talk about the the energy of the molecule, just few minutes. So in a molecule there are different types of energies. So the total energy of molecule, we can write it is equivalent to translational energy, E translational, plus rotational energy of the molecule, plus vibrational energy of the molecule, plus electronic energy of the molecule. So the total energy of the molecule, that can be said to be equal to translational energy present in the molecule, the translational portion, rotational portion, vibrational portion, electronic energy. So there are different forms of energy in the molecule. Now again, I'm just highlighting it here. So the integral energy of the molecule may be regarded as the sum of rotational, vibrational, electronic and translational energy. The translational energy means a molecule moves from, so translation energy means by virtue of which a molecule, let us say this is a molecule, it moves from one place to another place. So it changes the center of gravity, any movement of molecule from one point to another point, and it's called this energy associated called translation energy. So rotational energy in molecules, by virtue of which, let's say it's a molecule, the molecule undergoes rotation. So it undergoes rotation. Or we can also show the rotation of molecule along this axis. So molecule rotates along this axis like this, or it can rotation like this. So this is called rotational energy. Then we have vibrational energy in the molecule. Let us take a diatomic molecule, by virtue of which it undergoes back and forth. It's called a vibration, like a vibrating spring. So we'll assume this as a spring, and then this spring goes from this position to this position, this position. So mean to extreme, this vibrating spring. So the energy associated to the molecule, that's called as vibration energy. And then electronic energy is the energy which is associated with those electrons. So which is associated with the electrons. That is, the electronic energy is associated with the motion of electrons, while considering the nuclei of atoms to be fixed because they are very, very heavy. Fine. So it is just the motion of electrons here. So motion of electrons in different orbitals and energy levels. As we have mentioned that this energy E is equal to E translational plus rotational plus vibrational plus electronic, this is quantized in a molecule. Fine. So now this translational energy is very less. So this translational energy is very, very less than the other forms of energy in the molecule. Fine. So it's very, very less. Hence sometimes we could see that we don't write this. So we write electronic energy is a summation of rotational plus this is total energy. It's a summation of rotational plus vibration plus electronic energy in the molecule. So this is the total energy in the molecule. That is why in our syllabus, the main spectroscopy portion which we have to deal, that will be this ultraviolet visible, basically electronic, this radiation which leads to the changes here. The infrared, we will be dealing with the infrared radiations. Then microwaves, will be dealing here with the rotation changes in the molecule. So the rotational energy gets disturbed here. And then we have one more, that's radio waves, which leads to the change in the nuclear energy levels. Fine. So this is all about the basics. So I am just not going deep into the subject, just making it brief as much as possible, and look in terms of the examination pattern, because our examination is object type. So I'm trying to make it concise as possible. So in case you have any questions and queries, so you can, we can talk it later. So till for the day, So this is all about the electromagnetic spectrum and absorption of energy in the molecules. So the next lecture will be probably slightly dealing with these forms of energies, and then accordingly we'll shift the spectroscopies like rotational spectroscopy, NMR spectroscopy, and vibration spectroscopy and electronic spectroscopy. Anyway, this is not in our syllabus. Fine. So thank you.